So we are back to the try except block, right? So we'll continue where we left off. The try except block is a way to handle unexpected situations in your application so that it doesn't crash, right? Ideally, inside the except clause, which is also called the exception handler, right? We determine how we want our program to respond to the unexpected scenario, which is the exception. In our example, earlier we pretty much ate up the exception, if you remember this code. This is eating up. That's why I had an entire video talking about we should never do this. We just learned, therefore, we should at least do the first requirement. That is to tell the user what happened so that they are not in the dark. Let us change our calculator program so that this rule is followed. So now what I have done is I am still doing the first one wrong thing, which is I'm still catching exception as error, but at least I'm announcing to the user. So I'm saying skipping this one since the division cannot be done, and I'm printing that. So at least the user can get to know what went wrong. Let me actually run this to explain how this is working. Let's just ensure that we are on the we are on the right version. So okay, I immediately started off with giving a 0 in the divisor, and I get this message skipping this one since the division cannot be done and the error divisor cannot be 0. This error is coming from our util modules divide function, right? At least now I know. Then I can continue. So maybe I wanted to actually do 210 and I missed one and 0 happened. So at least now the user gets to know what went wrong and he can continue using the program, right? So this is surely a much better experience for the user. Well, this is good progress, but we are still not out of the woods, right? In our earlier section, we talked about, that is the previous video, we talked about 2 issues or crimes. We have fixed one, but there is still one more. We are still using the exception class in the except clause. I'm talking about this, right? So I did not cover this in detail earlier, the exception class thing. So let me do it here now. As I said earlier, in Python, errors happen at runtime, and the data around the error is provided as an object to us. So I'm going to do a brief interlude to talk a bit about objects, right? Now, objects need to be defined in terms of the structure of data they contain and the kind of behavior they exhibit. So, which means objects will have some data in them, which are sort of called properties, and they have some behavior, which is actually the methods in them. In most languages, and in Python as well, which is what we are interested here, right? This defining the structure and the behavior is done using a class definition. So object has some structure or some data and it has some behavior, which is some methods. And how do you say this object has this data and these methods? You do it by using a class definition. Most languages have this, some languages don't follow this, they follow a different approach, but Python follows this approach. So exception is actually a class that defines some structure and behavior, some data and some methods. Objects and classes are concepts which are part of object-oriented programming, and we are not planning to cover that in these sessions. But I am touching upon them very lightly so that we can better understand exceptions. Now, there is another related concept with respect to objects, and that is called inheritance. Right? The idea is that the world is full of general kind of objects and specific kind of objects. Let me take an example. Now, we have mammals, are a generic type of object or thing, right, or organism. Now, that type is alternatively called a class. Humans, dogs, cats, these are specific type of objects which are all mammals, and so all of them have same characteristics as mammals. Mammals themselves are a specific type of animals, right? So we have this, mammals exhibit or inherit properties or behavior of an animal, and human, dogs and cats, they show the properties and behaviors of, they inherit of mammal, right? So human is a mammal which is an animal. Inheritance means is a relationship between the types of objects. So these are classes, and there is a relationship. Mammal is an animal, human is a mammal, right? So this is a relationship between these types, these objects and corresponding types or classes. So when we work with objects in our code, Python will allow us to treat humans as mammals or animals. So if you have a human object and a method receives as a parameter a dog, then so if a dog is received and the method needs a mammal or animal, it will still work because dog is a mammal and an animal, right? But if you receive a dog and you want to treat it as a human, that won't be possible. A dog is not a human, right? So if a method wants humans, right, it can work with only humans. You pass a dog, it won't work. If a method wants mammals, then it can take a human, a dog or a cat, because it wants mammals and it will treat them as mammals, right? In terms of O, we call animal the parent and mammal the child. Mammal parent class, child class. Similarly, the mammal is considered the parent class, and human, dog and cat are called child classes. This is a very short explanation of inheritance, right? And this should be good enough for our needs. In the context of Python, right? Python exceptions, there is a similar setup of hierarchy of exceptions. I am going to show you a partial hierarchy which is relevant to our discussion. So there are many more classes in this hierarchy, but I am just going to show you some of them because that's what is important. Now, right at the center we have our exception, right? It inherits from base exception, but that's not very relevant here because just like we are interested in mammals, not all animals, right? So we are interested in exceptions. Base exception is there, but most of everything else sort of inherits from exception. Almost all classes or objects which represent error, if you see, we have seen zero division error. That is an arithmetic error which is an exception. So we have seen earlier errors, right? We have seen key error. It's a lookup error which is an exception. So almost every error, and we have seen value error which is directly an exception. So this means that Python will be okay to treat any of these errors, these errors as exceptions. Now let us look at our code again. So when you say this is the code, right, and here is So when you say except exception as error, what Python does is that any error coming from within the try block, because of some call which is happening within the try block, here the call happens, or any other thing you do within the try block. And if you remember, the actual util function is raising value error. I'll show you that. This is value error, but value error is an exception. So this except block will actually catch it. The handler may not be good at handling all kinds of errors, but that doesn't matter because every kind of error is an exception. So all kinds of errors will be caught by this exception handler because it's using the parent class, right? And which that can cause unexpected behavior because you may not be equipped to handle all kinds of errors here, right? So that's why it's a bad idea. Here it worked, but because there's only one kind of error, but other errors are possible in other programs. So we know that util.divide function throws a value error only. That is the exception it throws. So we could just handle that and show a relevant message to the user. Let us do that now. Okay, now I have changed this to a value error and I have changed the message to be a little more formal, little more clearer, I hope. I mean, it's up to you to decide what is the message. I find this better, so I've done this. Now, actually, let us run this. So, we see here skipping this division since the values provided are not divisible. Details divisor cannot be 0. Do you want to do more? I say yes, and I actually do what I want. Now, that is a good error message, and we have taken care of the second rule as well, right? 2 rules taken care. The third rule I think is already taken care because we stopped the program from crashing, we have given the message properly to the user, I think. So the user is happy, it's properly handled, so everything is good. But the story does not end here. Now, the library writer or our function writer, right, our utility writer, they suddenly notice that they are not really handling the input properly. What happens if the caller calls the divide function and sends 2 strings instead of the numbers? Okay, let us actually try it out. Try going to the Python REPL. Obviously, I will first import. So first I will import my package, utils package, and then I will call the divide method. So that bombs completely. Okay, we are getting some kind of error. It's very difficult to figure out what is happening really, right? Invalid literal for int with base 10 AB, it's not very clear. This is where we should be doing validation of input and raising proper errors to the user of the function. So let us actually do that. I'm going to write my validation code right before I start doing any work in the function. Now let us try out the improved version, right, in the REPL. Of course, I need to reload, right? Made the change. Remember, I had aliased it as U. As you can see now, it says only numeric values are supported as input. AB or 2 is not numeric. This gives a much better information to the caller, right? So, and we have used a built-in called type error, because as per the documentation, it is the error that is to be thrown when an operation is performed on the wrong type, right? In our case, division is not an operation you can perform on a string. So the exception type makes sense. That's why I chose type error. That's why you will have to consult the documentation and then take the call accordingly, right? Now let us go back to the calculator program. We'll actually try to execute it. Wow. Oh, we have a crash, right? We got a new error, this error, and our calculator crashed. So much for library upgrades, right? So this is something you will keep having to deal with in your developer life. You will use libraries and they will generally, that's why you have a concept of versions, right? So generally libraries will have versions and you use specific versions. As they change, as they modify, they will change the version and you will use corresponding versions. But remember, we always want to keep using later versions possible because they will have better code, they will have less errors. So you will have to keep moving to the upgraded libraries, upgraded frameworks, and as you do that, your own code might not work with them properly and you have to change, right? This is part of a developer's life. Now let us fix the calculator program. Since the library function is throwing a different exception, we need to handle that separately. How? It's pretty simple. I'll show you. So what I'm going to do is I'm going to add another exception handler, a different handler for this different exception. I already have one. I'm going to just add another one. So all I've done is I added a separate except block, exception handler, which actually handles the type error. That's what is a new exception thrown by, new type of exception which is thrown by the utils divide method. So I'm handling that kind. So it's a very specific handler, and my message is completely different. It's clearly telling that you are not passing numerals, and that's a problem, right? Unlike the earlier stupid message. Let us see it in action. So no crash. Skipping this division, since you are not passing numerals details, only numeric values are supported as input. ZBC or R12 is not numeric. So it's very clear and user has a choice to continue. Works like a charm. That is surely better, right? So with try except blocks, we can actually have more than one except blocks or exception handlers. This gives us better flexibility to handle different types of exceptions and in a totally different manner, right? So here I'm just showing different kind of print statements, but you might do other things, right? So as you do more and more development, you will find that this comes in very handy. There's one more aspect into covering exceptions, before we close it, and that I will do in the next video.